for CMPE 281 personal project for sharding. Sharding is just another name for horizontal partitioning, and it's mainly used for very large scale applications with lots of data, as it helps to minimize response times for database queries. So for the setup, I've kept a Mongo's instance. I have two sets of two shards, and I also have two config instances. I have shared the commands in my project journal here to set up a Mongo sharding cluster. I've added two shards, and due to time constraints, I'm not going into detail. I'll quickly move on to the experiment. So right now I've SSH'd into a jump box from where I SSH'd into my Mongo's instance, as all my sharding related instances are in a private subnet. I log into Mongo. I'll use CMPE 281. Okay, we enabled sharding. Now we will get a key. After that, we will shard the collection. So that is done. Once that is done, we will check the distribution of data on the different shards. As we can see here that nothing is there as of now. We'll next insert the BIOS data. This is the BIOS collection that I'm copying. And I'll just add it here, and all the data has been added. Next, we'll check the distribution of the data again. So we see that the data has been distributed in such a way that our replication set 1 has 77% of data, and the replication set 2, sharded replication set 2, has 22.78% of data. So this completes my submission for sharding. Thank you very much. My submission for the wow factor, I will try and demonstrate the replication of NoSQL databases in Amazon EKS. I've used this link here to refer to the documentation of Amazon EKS. I started with first creating the IAM user with roles. I've already created it, so I'll quickly go and show that. So these are the steps that I followed to create a user and attach it to a role. This is the user that I created, and these are the policies that I attach to them, like cluster policy, past role, etc. My next step was to create an Amazon EKC VPC in order to achieve network isolation. I have used Oregon region for this. We will quickly go to cloud formation. So as you can see, this is the VPC that I've created, and these are the worker nodes that this is the VPC that I have created. My next step was to download an IAM authenticator binary through which I can run AWS CLI. These are the steps that I followed to work on the same. In order to create a cluster, I used the following command. I'll quickly show the details of my cluster. Um, so as you can see, my cluster is in an active state right now. It's in the VPC with the subnets and has the following security group. My next step was to create worker nodes, EKS worker nodes, or the instances. These are the worker nodes that got created, like auto scaling group, etc. This is the configuration that I used to create them. My next step was to join them in a cluster, and using these commands I was able to create master pods and slave pods. I'll quickly show pods currently running. These are the services that are currently running. These are the pods currently running on my system. We see the master node and two slave nodes here. Next, we log into the master shell. Using this command, I have already logged into it, and I'm inside the Redis CLI. I'll try and display all the current keys that I have here. Let's try and enter a new key. You were successful in doing that. Now let's try and fetch this key from the slave nodes. I have already logged into one of the slave nodes and I'm inside Redis CLI. Let's do get main. So we are able to read it. I'll do the same here. Or now let's try and add something here in one of the slave nodes. So we are not able to write anything from the slave nodes. Let's try and add it in the master node. So that's a success. We can also fetch it back. Uh, so that's it. This completes my demonstration for the wow factor. Thank you very much.